All right, so I'm at the bottom of page 234. We're going to talk about two-column proofs. The first one is done for you. And essentially our goal here is they give us some introductory information. So in this problem, you have two triangles. You have triangle MQP, and the point of that triangle is facing up. And you have triangle NPQ, and the point of that triangle is facing down. These two triangles share a side. They share side QP. So you can read the given information, and when you write a two-column proof, that's always how you start. Or I'd say 99% of the time, that's how you start. For the purpose of geometry class, you're always going to start with the given statements in your proof. So they give us that angle MQP is congruent to angle NPQ. And then they also give us information that angle MPQ is congruent to angle NQP. So right off the bat, we have two sets of congruent angles from the given information. And you can see from statement number 3 they have listed that QP is congruent to segment QP. And that makes sense because it's the segment that both of those triangles share. Segment QP is on both of those triangles. And that's the reflexive property of congruence. So that's the reason that those two segments are congruent. And then the fourth statement, or the last statement, is always what we're trying to prove. We are trying to prove that these two triangles are congruent, and we now know that information because we have two sets of congruent angles, and the side that's in between those two angles, the included side, is also congruent. So the triangles are congruent by angle, side, angle. So let's look at an example from start to finish on the next page. And generally this is going to be the format. They're going to give you the statements, and we're going to have to supply the reasons. So we have kind of an hourglass shape here. We have two triangles that are meeting at angle E. It's kind of like those vertical angles are almost kissing each other. These two triangles are almost kissing each other at point E. So we're given that angle A, which is kind of the top left corner, is congruent to angle C, which is kind of the bottom right corner. They give us that information. They also tell us E is the midpoint of segment AC. So you have segment AC. It's kind of the almost, you can't really call it a transversal, but it's kind of like a transversal as it's a part of angle A and a part of angle C. We want to prove that these two triangles are congruent. Triangle AEB is congruent to triangle CED. So the first statement is angle A is congruent to angle C. That is a given piece of information. The second statement says E is the midpoint of segment AC. That is also a given piece of information. The next statement says AE, segment AE, is congruent to segment CE. So we have to think, okay, how do we know those two segments are congruent? Well, we know by the definition of a midpoint. A midpoint, by definition, is the halfway mark from one end of that segment to the other. So if E is right in the middle of segment AC, that means the smaller segments are congruent to one another. So the reason is definition of midpoint. So now we have one set of congruent angles. We have one congruent set of segments. Statement number 4 is angle AEB. It tells us it's one of those angles that's kind of kissing in the middle, is congruent to angle CED. And I think you know what those angles are called and why they're congruent. Those are vertical angles. You can say vertical angle definition. And now we have two sets of congruent angles and one set of congruent sides. The side is the included side that's in between the two angles. So these triangles, step 5, statement 5, triangle AEB is congruent to triangle CED by angle, side, angle.